All right, I want to look at L'Hopital's rule with you. This is an interesting rule that allows us to simplify certain limits and compute certain limits that up until now would have been beyond our reach. So let's take a moment or two and work some examples and just see where we've been, where we've come from. So first example, looking at this limit, and I want you to think about the form here. The form is, well, let's think about it. As x goes to 1, the top goes to 1 minus 1 is 0, bottom goes to 0. So let's actually write it down. The form is 0 over 0. We were able to solve this limit by factoring the top and the bottom, and we canceled out the x minus 1s, and we get the limit as x goes to 1 of x over x plus 1, which is 1/2. I'll squeeze that in there. So in that case, even though the form was 0 over 0, which is indeterminate, we were able to use a canceling technique and work out this limit. The next example, the same thing. The form, for example, 2 is indeed 0 over 0. However, back in the good old days of chapter 1, we were able to figure this one out using a picture. We used the squeeze theorem and a clever picture, and we were able to sort of show that this limit is actually just 1. And we'll say see proof by picture from chapter 1. Okay, and now we come to this limit. We've gotten some more complicated functions since the days of chapter 1. And now we look at this limit and we see again that the form here is as before. X goes to 0, this goes to 1, 1 minus 1 is 0, so 0 on top, 0 on the bottom. The form is 0 over 0, but at this point we're sort of stuck. And so we need some new theory to help us figure this out. And so let's just say stuck. Okay, and so the theory is L'Hopital's rule. And so I want us to look at the setup. So I'm going to take two functions. I'm always interested in quotients, fractions of functions, two functions that are differentiable. And I'm going to assume that one of them, let's say g prime, is going to be the bottom function, is not 0 on some open interval I containing our point of interest. And I'll say a little bit later that this point of interest, maybe it's actually at infinity, whatever. But the point is we do need the derivative of the bottom function to be non-zero. So let's say if either the limit, you know what, let's say it like this, I'm sorry. If the limit as x goes to a of f of x over g of x has form, let's say has the form 0 over 0 or infinity over infinity, then the limit as x goes to a of f of x over g of x is the same thing as the limit as x goes to a of f prime of x over g prime of x. And we should say provided that the second limit actually exists. So right, and when I say exists, I'm going to actually include infinity. If this one is blowing up to infinity, so is this one. And so a couple of comments. Actually, I'm going to scroll this up here. I dropped these down, but we'll slide these up. Okay, so a couple of comments. First off, before we look at the remarks, I want you to realize we're not doing the quotient rule here. That always makes me sad when I see people make that mistake, because the quotient rule is going to be kind of nasty. You're going to get f prime g minus f g prime over g squared, not really simplifying anything in many cases. Whereas here, in this situation, we're saying just take the derivative of just the top and then divide by the derivative of just the bottom. And many times that actually can make life better. Okay, so first comment, L'Hopital's rule is valid for one-sided limits and limits at infinity. Second comment, when you use L'Hopital's rule, you need to indicate to your reader that you're using L'Hopital's rule. So we usually write an L over the equal sign, and I'll show you what I'm doing. I'd put an L like that when you do it. Otherwise, your reader, if they aren't aware of what's going on, is going to wonder, what on earth? That's not how you do that. So you want to indicate L'Hopital's rule using an L. Third thing is 0 times infinity, infinity minus infinity, 0 to the 0, 1 to the infinity, infinity to the 0. All of these are indeterminate forms, which mean more work for you. So let's just summarize L'Hopital's rule. So there are 2 indeterminate forms that you can run into, and well, there's a lot more than 2, but the 2 that we're interested in are 0 over 0, infinity over infinity. If you hit either of those forms, then you can take the derivative of the top and the derivative of the bottom, and the limit of that function is going to be the same as the limit of your original function. One last comment on the infinity over infinity. It doesn't matter if like the top is going to positive infinity and the bottom is negative, no problem. Or if the top is negative, the bottom is positive, or if they're both negative, any of those combinations are all fine. So that's L'Hopital's rule in a nutshell. In the next video, we will work out some examples.